So the first question here is which is the correct orbital diagram for a carbon atom? So we have to count over from left to right on the periodic table. So it'd be 1s2, 1s1, 1s2, 2s2, 2s1, 2s2, and then 2p1, 2p2. So if you were to write it all out, we have 1s2, 2s2, 2p2. And the way you write that with boxes is you just have to skip the whole first orbital, and then we write our box right here. Is that enough boxes left? Actually, we'll skip the first orbital. Very nice boxes. So for the 1s orbital, you have to fill it up. So 1s2, and then 2s2, and then for 2p2 it can hold 6 electrons, so we have to have 6 boxes, and then you would fill it up like this, as they have to be once they start getting full, they like wrap around. So the correct answer would be D, which looks like this one.
So for number 2, we're trying to find the electron configuration of a copper atom. So we're going to start on the periodic table from the left, starting at hydrogen, 1s2, 2s2, 2p6, 2s2, 3s2, 3p6, 4s2, 3d, and then copper is at 3d9. So copper is at 3d9, so it has 29 electrons. So on here, we're going to do it on paper. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Alright, so 1s2 has 2s2 has that. 3s2 has that. 3p6 has 4s2 has 2 of those, and 3d9 has 9 of those. Alright, so we want the d orbital to be stable at all times. So to do that, to make it stable and have 10 in its orbital, we're going to take 1 from the 4s and make it 4s1, put it right here to make it 3d10. Alright, so now when we write it out, we've gone from 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9, 2, 1s2, 2s2, 2p6, 3s2, 3p6, 4. Actually, no. You put the 3d in front now. So 3d10, 4s1. Now, that is C right here. It can be in either way. These are interchangeable. All right, so the answer is C.
So the question is, which is the correct orbital diagram for the 4s and 3d orbitals and the Fe3 plus ion? So the way we find this is we look at the Fe atom, and we go 4s2, which is here, and then 3d 1, 2, 3, 4, 5, 6. So we can find that iron usually looks like this right here, which has 6 electrons in the 3d10 orbital. However, because it's the 3 plus ion, we have to remove 3 of these electrons, leaving us with 4s2 and then 3d3. So that means our answer choice for this question would be B.
All right, so for this question number 4, we're trying to find out which statement is correct about a potassium plus ion. So we're going to go through each answer choice. So A, it contains 20 electrons. Potassium on this answer choice, on this question, has a plus, so it's minusing 1 electron. And this right here shows the amount of protons in this ion. So we're going to minus 1 from this to show how many electrons it has. So 19 minus 1. So we have 18 electrons in this ion. So we can cross out these two since they both show that they have 20 electrons and 19 electrons when it actually has 18 electrons. We're going to go to answer choice B. It contains 20 protons. I've already said that it contains 19, and this right here shows that it has 19 protons, not 20, so we can cross out answer choice B. All right, so now we can show that it's answer choice C by doing the atomic mass minus the protons. 39 minus 19, which equals 20 neutrons. And that is answer choice C.
So question number 5 is which species contains 10 neutrons and 8 electrons? So the way we find out, like how Jaden explained in the last question, you have your charge right here of the electron, and then you have your atomic mass, and then your number of protons. So for the first one, we have, what is it, 19 atomic mass, 9 protons, and then a charge of -1. So that means you'd have to add an electron. So we'd end up with 10 neutrons because you can subtract the amount of protons from the atomic mass. But then you'd also end up with 10 electrons because you have to add 1. And then the amount of protons will tell us how many electrons it'll have if it's a neutral charge. So we'd have 10 electrons. So it's not A. So then for number B, we would have, we have a 19 and 9 with a positive charge. So that means that we have to remove an electron. So we also would have 10 neutrons here. But then we have to remove an electron from the bottom. So we have 8 electrons. So that means we have found our answer, which is B. I can just go through the rest of the problems really quick. For oxygen, 16 minus 8 would be 8 neutrons, and then it has a neutral charge, so it have 8 electrons, so it wouldn't be oxygen. And then for neon, we would have 20 atomic mass and then 10 protons, which means it would have 10 neutrons in it. However, it has a neutral charge, so that means we'd also have 10 electrons, which is not correct. So the answer choice is B.
Okay, so question 6 is which electronic transition occurs when a gaseous hydrogen atom is in its ground state is ionized. So when you're transitioning from one form to another, when you're ionizing something, there's a convergence limit. And this convergence limit is n equals 1 to n equals infinity, because electrons will always be infinitely far away.
Because you know Saturdays they have the bigger one.
This. So n will always equal infinity. So because of this, for 6, the answer will be B, n equals 1 to n equals infinity, because of the convergence limit when you're ionizing something.
So for question 7, it says which series of transitions occur to produce the discrete lines that occur in the visible region of the emission spectrum of hydrogen. So in the hydrogen spectrum that I've drawn here, that is exactly how it is in the IB textbook. It says that visible light occurs when the lone electron falls to the second energy level. So anything starting from this second energy level right here and up would be in the visible region. As you can see, it's also in the excited states. So it would be n equals 2, since it's the second energy level, and anything above that, so 3, 4, 5, 6, 7, 8. So 3, 4, 5, 6, 7, 8 would be in the visible light spectrum. So that on the answer sheet is C.
So question 8 is which transition will have the highest energy? So what we're looking at right now is that currently these ones are the first ionization energy because they're removing one electron from the it's removing the first electron, as we can see. So this one is just not going to be the answer off the bat. And then so for this one, it's also only the second ionization energy, so it won't be this one. So these ones are the third ionization energy. As you can see, we go from having a 2 plus charge to having a 3 plus charge. So that means if we want to draw our little ionization energy graph really quick, we could show it like this. So these ones, this is the first, second, third. Wait, I need to actually make this accurate. So the way we find out which one of these would have the higher ionization energy, you think it might be AL because it's just simply higher up. That's what I thought at first. Has higher electronegativity. I thought it would have a stronger bond. But however, if you go back 3, if you remove 3 electrons, you move 1, 2, 3, you'd end up here. However, with Mg, you go 1, 2, and 3, and you end up on a new whole orbital. So that means that, here, if I want to draw this really quick. So these are the B3S2 and then 2P6. So for AL, am I starting in the right spot? Oh yeah, this one starts on the 3P, so it would start here, right? Yeah. So it'd start here, and then it'd go 1, 2, 3, so it ends up right here. However, magnesium ends up 1, 2, and then 3. So you have to go through this whole energy jump to remove it, and then we actually end up with a whole set of valence electrons, so the orbital will be full. So it'd be Mg, which means that this D will be the right answer.
So for question 9, we're trying to find out which group in the periodic table this element belongs to. So as we can see, the numbers here are 707, 1410, 2940, and 3930. The jump is between 3930 and 7780. So it has 4 before there's a big jump. So we're gonna start from the beginning on this periodic table. 1, 2, 3, 4. And that comes in group 14, so the answer here is C, 14.
So for number 10, we have a little algebra problem. So as what are X, Y, and Z when table is completed? X is just the symbol of the element. So it gives us a few givens. So right off the bat, it says for all of these answer choices that Y equals 24 and that Z equals 52. So we just fill these out really quick. So for all of these, we remember that here with our little notation, that up here is the atomic mass, and here is the number of protons, and here's the charge. So because we're given the mass, it should be 52, and then the number of protons is 24. So then all we need to do is find the charge. So it says our number of electrons is 21. So that means if there's 24 protons and only 21 electrons, that means we have a charge of positive 3, 3 plus. So this is our this is our answer right here. But we need to find the element in the periodic table first. So it has the number of 24. So it is, what is this, chromium. So our answer choice would be C, which is 52, 24, Cr3 plus. All right.